similar to what we were doing before. So now we're going to find the values of t where the tangent line is vertical. So vertical slope would be where the denominator, right, dy over dt, dt, dx over dt, where the denominator is 0. But again, make sure that you're setting up the whole thing to get rid of any canceling. So 3t squared minus 1 from the derivative of the y, 2t minus 1, derivative of the denominator. So there's no canceling that will go on. So when the denominator is 0 is when the slope will be vertical. So t will be 1/2. All right, so let's look at this one. So y prime would be 2 cosine of t. And derivative here would be 8 cosine of t times the derivative of cosine, which is negative sine. So it's necessary to cancel. So I get 1, negative 4 sine of t. All right, so I'm looking to find when sine of t is equal to 0. It says all, so that means I have to encapsulate everything with the k pi. So t will equal k pi. All right, so let's find the equation of the tangent line. So let's practice this one more time where I'm giving you a point. So the derivative of this will give me a 2 sine of t, and derivative of x will give me a 2, and then it'll be a minus pi cosine of t. All right, so I need to find the t value to be able to plug in, right? So that's where I got to set the x, which is equal to 0, equal to 2t minus sine of pi, and the y is got to equal to 2, and it's got to be 4 minus 2 cosine of t. So they have to both be true at the same time. So what does t have to equal? So looks like, if I'm even just looking at this one, I think t's got to be 0. Does t equal 0 work here? Cosine of 0 was 1, 4 minus 2 is 2. Aha! T equals 0 works. Okay, so I'm using t equals 0, so I get 0 over 2 minus pi. So that is 0. So the slope is 0. So I have y minus 2 is equal to 0. So y equal 2. All right, so let's move on to the concavity of a curve. So concavity, remember, comes from the second derivative. Be really careful. It isn't just take the derivative of each of them again. Because we know that y prime is dy over dt over dx over dt, right? The second derivative is very different. It says take the derivative of y prime and put it over the derivative of x again. Very odd definition. Okay, so first you have to go find y prime. So let's go do that. So the derivative of this will give me 1/2 t over 1/2 t to the negative 1/2. So that gives me t to the 3/2. So that's y prime. So the second derivative, y double prime, or another way of saying that is d squared y dx squared. And remember that comes from this, like saying this is squared, right? Is take the derivative of y prime and put it over the derivative of x again. So I'm just going to write it out so you really see it. So the derivative of y prime, put that in for y prime, and then I'm going to take the derivative of x again. And so x is this, right? So take the derivative, 3/2 t to the 1/2, and then take the derivative here. Okay, so let's multiply by reciprocals. So this turns into 3, and then this turns into t. Okay, so that's the second derivative. So what do they want? They want what is the concavity at this t value, at this point. So that meant that 2 had to equal root t, and 3 has to equal 1/4 t squared minus 4. So I think we came up with this before, that t had to equal 4. Because I got root 4 is 2, 16 minus 4 is 12, divided by 4 is 3. Okay, so now I'm going to put in t is 4, so I get y double prime is 12. So if the concavity is 12, that means the curve is concave up, right? So the second derivative is 12. If it's positive, that means the it is concave up.